Hello dear friends, welcome to BYJU'S Exam Prep and I welcome all for this GATE Champions series. We already completed two topics. One is logic and the other one is counting. The next topic under Discrete Mathematics is a combination of topics like sets, relations and functions. So in today's lecture we take up some interesting questions on sets, relations and functions. Hope I am audible to all of you. The problems generally people ignore, but these are the most difficult problems for most of the people because this is the topic which most of the people ignore under discrete mathematics, sets, relations and functions. So hi Lalit, very good evening sir, very good evening Lalit. So let us start with today's class. And this is about me. Okay, they will not ask you in GATE examination about me, so it is only for introducing me. Okay, I am having 20 plus years of teaching experience and I am associated with Byjus from past 1+ years. And we are working on a different project called Recorded GATE Content. First of its kind, we created visualized animated content for you, my dear friends. Okay, now under Byjus Exam Prep app, Learn with Video Lessons category, you can find all these subjects which were recorded by me. Discrete Mathematics, Algorithms, Engineering Mathematics C and Data Structures. Okay, so I want all of you to go through these lectures. Okay, those who purchase the course can access all the videos. Even otherwise, some of these videos you can watch for free, my dear friends. Am I clear? Right. So without wasting much of your time, let me start with today's topic. That is, what is it? Sets, relations and functions. Workbook. Problems we solve it. You are all ready, hopefully. So let us take the first problem and solve it. Please answer your question, sir. I'll wait for 10 to 30 seconds for each problem. Of course, after regular 15 seconds gap, because after I tell, it will reach you after 10-15 seconds. Then I'll wait for 15 more seconds. Approximately 30 seconds I'll wait for your response. Then I'll solve the problem. So please answer this question, my dear friends. Waiting for your response. Lalit, and what about the regular students who join the class? I think this is Sunday, so most of you might be taking rest. Yeah, C. Lalit Yadav says it is C. Sorry, let us see this solution, sir. A complement union A complement minus B whole complement whole complement. So this is a problem. So let us solve this problem, my dear friends. A complement union. See, this is A minus B. A minus B can be written as A and B complement. This is the rule. So same fellow and complement of this fellow, whole complement, whole complement. Good evening, Anant Mohan. Very good evening. Try this problem, sir. A complement union. What is this? De Morgan's principle, which is A union B. Because A complement intersection B complement whole complement is A union B. And for this entire fellow we have whole complement. Now this can be written, because all are unions only, this can be written as A complement union A union B by associative property. A union A complement is, hi Kunal More, good evening, hello sir, very good evening and hello sir. This is universal set union B, whole complement. Universal set union any set, universal union any set is universal set only, because universal set dominates with respect to union and its complement. What is complement of universal set, sir? It is empty set. So Lalit changed his answer 2 times, now 3rd time. Now he says universal. So you changed your answer 3 times, Lalit. So the answer for this problem is A. I told you this topic looks very simple and most of the people ignore because they feel it is theoretical. Okay, generally some people also have misunderstanding, like discrete mathematics is dry subject, okay, theoretical subject. Acha, you are telling stepwise answer. Okay then, fine. But initially you said C, that was wrong, right? Nice, good. So that is the method, my dear friends. I am just using, no problem. It happens for everyone, my dear friends. It is common, very common for discrete mathematics. But it is not theoretical, sir. It is problematic, only completely problematic. Okay, logical. Next one, the relation R on set of integers, okay, defined like this: A related to B if and only if A plus B is even. What type of, hi AB, what type of relation is this? What type of relation is this? Is it reflexive? Is it symmetric, antisymmetric, transitive? So sometimes this type of questions can be multiple select questions also. So you have to verify, my dear friends. You have to verify this. Okay. So let us verify and solve this problem, my dear friends. Let us verify and solve. Now first one, here they are all defined on set of integers. That is, the set is set of integers. R is defined on set of integers. Okay, R belongs to set of integers means R belongs to Z plus, or R is subset. That is a better word, no? Belongs instead of belongs, subset. R is subset of Z cross Z. ABD. Now ABD videos feel very happy with this solution because I am creating it for him. Now let us see reflexive or not. Reflexive means what, sir? A should be related to itself. That means A plus A must be even. But A plus A is what, sir? 2A. Obviously it is even. Therefore, it is reflexive. So A related to A is satisfied. Okay, of course, even though here I not mentioned about irreflexive, whenever it becomes reflexive, it cannot be irreflexive. So it is reflexive, but it is not irreflexive. Irreflexive, no. Okay, now of course that is not asked, but just for completeness I am just doing it, sir. See, reflexive means what, sir? A should be related to A. For every A belonging to set of integers, A should be related to itself. That is, A plus A must be even. Got it? Next one, symmetric. What do you mean by symmetric, sir? If you take A related to B, you have to prove B related to A. Of course, it is obvious because A related to B means A plus B is even. That means B plus A is also even. Whenever A plus B is even, B plus A also will be even. So obviously this is satisfied. Therefore it is symmetric. That is clear. Next one, antisymmetric. See, my dear friend, to prove it, we have to write a general rule, but to disprove one counter example is enough. To disprove something, one counter example is enough. So I'll just give one counter example to prove that it is not antisymmetric. So let me take example to disprove that it cannot be antisymmetric. See, what is antisymmetric property, sir? If A related to B and B related to A, then A should be equal to B. So this is what antisymmetric property says. Now you see, 2 plus 4 is even. That is 2 related to 4. Also, 4 plus 2 is even. Therefore, 4 is also related to 2. But 2 and 4 are not equal. Therefore, it is not antisymmetric. 1, 2, 3. See, with one example you cannot prove, sir. If you want to prove, you have to prove for everything. Disproving can be done with one example. Proving cannot be done with one example. Please remember, this is the most common mistake. Antisymmetric, if A related to B, then B must not. It is wrong, sir. That is, antisymmetric is wrong. That is the definition. Lalit, what you written is definition for asymmetry. If A related to B, then B should not be related to A is definition of asymmetry. What you written is definition for asymmetry, not antisymmetry. Okay? Please note that. Okay? That is not, that is definition for asymmetric, not for antisymmetric. Okay? Nice. Now comes the transitive. Now to check the transitive property, what we need to do, my dear friends, what we need to do, okay? I take A related to B and B related to C. Then I have to prove A related to C. Okay? Now A related to B means what, sir? A plus B is even number. Similarly, B related to C means B plus C is even number. B plus C is even number. Now, I want to prove A related to C means A plus C must be even. Now, please tell me when sum of two numbers will be even. When sum of two numbers will be even. If both are even like 2 plus 4, it will be even. Or if one is odd, the other one is odd, like 3 plus 5, then also sum will be even. Correct or not? Both must be even or both must be odd, then the sum will be even. So, then the sum will be even. So, if I say A plus B even, A, B both must be even. Suppose if B is even, in this particular case, because this sum to be even, C also must be even. Then what is the fate of A plus C? Then what is the fate of A plus C? See, in the first case, A is even, C is also even, this sum will become even. Suppose if you take the second case, where A and B both are odd. Because B is odd, because the sum B plus C is even, definitely C also must be odd. So, in this particular case, both must be odd. That is, both A and C are odd. Whether both are even or both are odd, that sum will be even. That means A related to C. That means A related to C. Yeah. Got it? So, based on that, what happens, sir? Based on that, what happens? A related to C means it becomes transitive. So, what can you say about it? It is reflexive S, it is symmetric S, it is transitive S, but it is antisymmetric is wrong. So, it is a multiple select question. ABD is the answer. ABD is the answer. All of you able to follow? Is the idea clear? Yes or no? Please tell me if you have any doubts. Please tell me if you have any doubts. Good. Next problem. Next problem on your screen. Next problem on your screen. R is a relation on positive integers. R is a relation on positive integer. That is, R is a subset of Z plus cross Z plus. This is given. You don't have to do anything, sir. It is given. Now what we need to prove? Which of the following options is correct? See, actually there are total 6 types of relations on A. Mostly we are interested in these 4. That's why I just given these 4 options here, sir. So generally sometimes irreflexive and asymmetric also will be used. But we are not very much interested because there are 2 important types of relations. One is called partially ordered relation and the other one is called equivalence relation. Partially ordered relation is a relation which is reflexive, antisymmetric and transitive, whereas equivalence relation is a relation which is reflexive, symmetric and transitive. So because of that, these 4 types are very important. So we are trying to verify them, my dear friends. Am I clear? So let us see what is the property. What is the property here? Now first let us see, is it reflexive or not? I want to verify whether it is reflexive or not. What is the relation? A related to B if and only if GCD of AB is equal to 1. So every element should be related to itself. See, what do you mean by A related to A means? What do you mean by A related to A? GCD of A should be equal to 1. But can you say GCD of A is always 1? Can you say GCD of A is always 1? Okay, so obviously GCD of 1 1 is 1, that is fine, but for 2 2 it cannot be 1. So it is not true for every fellow. So this is not reflexive. This is not reflexive. See my dear friends, see job is first priority with 116 rank. If you can get a good MTech, okay. See sometimes what happens when there is some kind of recession in the market, the best time where you can go for higher studies. That is the best time where you can go for higher studies. That is the opportunity we need to take, my dear friends. So once with MTech there is a possibility. See this, market may be down for 1 or 2 years. Again market will come to normality. So then in this particular time, if you prepare for or if you go for higher studies, then you are eligible person in the market. You are market ready, then you can go for other subjects. Even this GATE score is not just valid for 1 year, sir. It is valid for 2 years. So don't lose hope, my dear friends. Just by not getting a interview call for few PSUs, you cannot say that it is gone. And you got 116 rank. You got 116 rank. Okay, you should be the motivation for many people. Please remember that. Got it? Now it is reflexive. Now it is not irreflexive also. It is not irreflexive also, because GCD of 1 1 is 1. Because of that it is not irreflexive also. It is not irreflexive, Lalit Babu. Got it? Triple R. Okay? Irreflexive bhi nahi hai. It is not irreflexive. Now if you take this, A related to B if and only if GCD of AB is equal to 1. Now symmetry. What about symmetric? See, symmetric means if GCD of AB is 1, GCD of B also obviously 1 only. So GCD of AB is 1. This means GCD of BA different hoga kya? Same hi hoga. It would be same. It would be exactly same. So no problem. This is done. Symmetric is done. Symmetric is done. Now asymmetry. Asymmetry nahi hoga. See, when it is symmetric with this AB BA pairs, okay? AB BA pairs, if it is symmetric, it cannot be asymmetric. So it is not asymmetric also. Of course, that is not asked, but you can verify that. Next one is, that is fourth. Next one is antisymmetric. See, what do you mean by antisymmetric? If AB related and BA related, A must be equal to B. But here you see GCD of 2 3 is 1 and GCD of 3 2 is 1. But is 2 and 3 are equal? 2 and 3 are equal nowadays? Never. Not nowadays. Never they are equal. So they are not equal. Therefore it is not antisymmetric. It is not antisymmetric. ये antisymmetric नहीं है. And the last one is transitive. होगा कि नहीं होगा? Transitive. Okay, let us put some numbers properly. 3, this is 4, then this is 5. We have verified everything now. Let us write down everything. Transitive, yes or no? See, if you want to say no, you have to give a counter example. One example is enough to disprove something. One example is enough to disprove something. See, now, for example, RR want to say that GATE is useless. Okay? Then he need to prove that everyone who got 116 are not getting any job. It's not like that, right? So it is just, you have to prove it means for every example you have to prove it. Okay? It is just a counter example. To disprove something, you need counter example. To prove something, you have to prove for every value, my dear friend. For every possibility, you have to prove it. Got it? 3 to 5, 5 to 6, then 3, 6 can't be related. Super. Oh, wow, wow, wow. No problem, sir. See, he's having his, see that is the time of, happens for everyone, no problem. Don't, I'm just trying to motivate him, don't say that way. Okay? This time you try for good rank AB, this time you try for good rank and be the motivation for the next generation or next class students. You are juniors. Okay? Yeah. Transcript. Now look here, as many people are saying 2, 3 GCD is 1 and GCD of 3, 8 is 1, but GCD of 2, 8 is not 1. Therefore, it is not transitive. It is not transitive. So, out of this, what happened, sir? It is symmetric only. Wow! Someone already answered, right? Only symmetric. Lalit, super. Lalit, you answered superbly. Properly. Perfectly you answered, sir. Perfectly you answered. Nice. Agla samasya on your screen. Now here, yes. Don't get demotivated, sir. You can talk to your civil engineering faculty. They'll guide you in much better manner. So what is the better opportunity with that rank? Okay, get connected with some of the civil faculty. Okay, there are many civil faculty. You please connect to one of the civil faculty. Yeah, Anant Mohan says only B. Oh, some of these questions can be MSQs also. I also given some MSQs. Yesterday I not given any MSQs because in counting MSQs are not good options. Am I clear? Yeah, MSQ. What happened? Now look here. Here A is this set. R is a relation on A. So ordered pair is mapped to ordered pair. That is, we are trying to find the relation between ordered pairs. And this is the relation, sir. Now look here. AB related to CD. AB related to CD if and only if A plus D is equal to B plus C. See, it is simply like this, sir. It is simply like this. A plus D, the first coordinate here and second coordinate in the second pair, sum, and second coordinate and first coordinate in the second ordered pair sum must be same. So this sum and this sum must be equal. Then see that you have to prove it generally. Lalit, what you done is correct. That is not possible like that, De Villiers. Okay, so what? Again ABD will feel very happy today then. So let us try reflexive. See, for reflexive what happens, whatever element you take, that element should be related to itself. That element should be related to itself. That means sum of these two fellows must be equal to sum of these two fellows. Is it happening? Is it happening? Is it happening? A plus B is B plus A. Happening, therefore it is reflexive. ट्रांजिटिव फेल हो रहा है. सो फेल हो रहा है तो प्रूव करना पड़ेगा विथ एग्जाम्पल. काउंटर एग्जाम्पल मिलना चाहिए आपको, अदरवाइज आई मे गिव करेक्ट एग्जाम्पल. रिफ्लेक्सिव, देयरफॉर इट इज नॉट irreflexive. Irreflexive fails. Let us wait. Symmetric. Is it symmetric? That is, AB related to CD. That means what, sir? A plus D is equal to B plus C. Now we have to check whether CD related to AB. We have to check whether CD related to AB or not. See, for this what happens? C plus B. Actually you can write this as C plus plus B is equal to D plus A, no? Same, B plus C is C plus B, A plus D is D plus A, and because of that, this also happening. Therefore, symmetry is happening, my dear friends. Because symmetry is happening, asymmetry fails, antisymmetric. What about antisymmetric? Just one counter example is enough. You can take 2, 3 related to what, sir? Here 4 and here 5 you keep. 2 plus 5, 3 plus 4. Correct? And 4, 5 related to 2, 3. Because 4 plus 3 is 2 plus 5. Satisfied. But order pair 2, 3 is not equal to order pair 4, 5. The order pairs are not equal, therefore antisymmetric failed. Now the question comes about transitivity. The question is about transitivity. So let me try transitivity here. Let me prove transitivity here. Transitivity or transitive property. Now let us consider AB related to CD and CD related to EF. Now we have to prove that AB related to EF, that is A plus F is equal to B plus C. But first of all, what do you mean by this? A plus D is equal to B plus C here, and here C plus F is equal to D plus E. This is what we know from the given information. Now what I do, I add these two fellows. So when you add, what happens? It is A plus D plus C plus F is equal to B plus C plus D plus E. Now here C gone, D gone. What is remaining? A plus F, B plus E. That means AB related to EF. Transitive हो रहा है. It is transitive. Is that clear? See, now this number of students watching is very demotivating, depressing, but still I am teaching or not? What else? See whether 1 plus 4 is equal to 3 plus 2, 3 plus 6 is equal to 4 plus 5. Oh, it is happening. So 1 plus 6 is 7, 2 plus 5 is 7. You only proved it. You are giving again an example. With example you cannot prove it, sir. With example you can disprove. Yeah, I proved generally, no? How can you say that it is not transitive? I proved it in a very general case. It is reflexive, it is symmetric, and it is transitive. It is an equivalence relation. Reflexive, symmetric, and transitive, therefore it is an equivalence relation, my dear friends. This was an old GATE question, so I just taken this example only because there are 4 different forms in this. First one I think we already verified, no? First one was already verified, reflexive, symmetric and transitive. So this is equivalence relation. A relation which is reflexive, symmetric and transitive is an equivalence relation. Now out of the next 3, which of them are equivalence relations? So let us see R2. Let us see R2. R2AB, that is A related to B, if and only if A plus B is odd. Tushar Sisodia, very good evening, sir. See here, Don't unnecessarily verify everything, waste of energy. You just need to verify what is required. Equivalence relation means what, sir? What do you mean by equivalence relation? A relation R on A which is reflexive, symmetric and transitive. A relation R on A which is reflexive, symmetric and transitive is equivalence relation. Just you need to check these three, my dear friends. Don't unnecessarily verify other things which are not of any use for you. If any one of them fails, it is gone. So start with right. So A related to B if and only if A plus B is odd. Now is it reflexive? Is R2 reflexive? You want sum to be odd. Can you get A plus A odd? Is it possible ever? Is it ever possible A plus A is equal to odd? Is it possible? Never, because A plus A will be 2A. 2A will be even. So it cannot be odd, not reflexive. Not reflexive, therefore it cannot be equivalence relation. So it cannot be equivalence relation. It cannot be equivalence relation. How to find number of equivalence relations on a set? Bell number. There is something called bell number. Use bell number, you can get the answer, my dear friend. Bn, which is given by the formula. Yeah. I'll tell you if possible. Next one is R3 related to AB. R3 related to AB. If and only if A related to B, if and only if their product is greater than 0. A into B should be greater than 0. Now you know reflexive. Let me check reflexive. A into A is A square. And it is on non-zero rational numbers. 0 is not there. So definitely it is greater than 0. Definitely, because A is non-zero. I think n minus 1 Ci. I am sorry, it is n minus 1 Ci. It starts with n minus 1 Ci. Bi. And that is a formula for bell number, my dear friends. Sachem B Nayak, that is bell number. Use that, you will get the answer. For example, B2 will be 1C0 B0 plus 1C1 B1, which is nothing but 2. Okay, B3 will be 2C0 B0, 2C1 B1, 2C2 B2. Because B0 B1 are the base conditions, use it, you will get all equivalence relations, my dear friends. At least up to B5, we generally ask student to remember. We ask student to remember at least up to B5, my dear friends. Okay? Please remember at least up to B5, it is good for health. So B3 is 5, B4 will be 15 and B5 will be, someone should help me using this formula. Simple, sir. B3 means you start with 2, 2C0 B0, 2C1 B1, 2C2 B2. B4 will be 3C0 B0, 3C1 B1, 3C2 B2, 3C3 B3, like that. Not 34, no. 34 is wrong answer. Please check. No need of studying because the proof is beyond the scope. Proof is beyond the scope. For that we need to understand partitions. That is, D5 is also wrong, sir. Yeah, D5 is also wrong. Okay, anyhow. So reflexivity is satisfied. Next, symmetry. Now A into B greater than 0 means B into A greater than 0, therefore symmetric. That means A related to B means B related to A. Transitive. Is D5 42, 34 correct? Someone please tell him. D5 34 is also wrong. That is also wrong. 44 D5. I generally feel that I don't remember, but you are looking better than me because I always go with the formula and get back to the numbers. Transitive. Now look here. A related to B and B related to B related. Oh, what happened? B related to C. That is A into B greater than 0 and B into C greater than 0. 52 correct. 52 correct. You remember some values. 52 is correct. Satyam correct. Super. A into B greater than 0, B into C greater than 0. That means both must be positive or both must be negative. B is positive, definitely C must be positive. If B is negative, C must be negative. So that means A into C, if you consider, both must be positive or both must be negative. In any case, A into C is greater than 0. Therefore, it is transitive. Therefore, it is transitive, my dear friends. Hope you understand. So, it is transitive. That means it is equivalence relation. It is equivalence relation. So, the last one, mod A minus B less than or equal to 2 over natural numbers. R4, A related to B if and only if mod A minus B less than or equal to 2, where R4 is a relation on set of natural numbers. It is on natural numbers. It is on natural numbers. Very good. So now let us check it. Reflexive. Is it reflexive or not? Mod A minus A. Because A should be related to UNM. Mod A minus A should be obviously 0. It is less than or equal to 2. Reflexive. It satisfies. Symmetry also it satisfies. Because mod A minus B less than or equal to 2 means mod B minus A is also less than or equal to 2. Means A related to B means B related to A satisfied. Yeah, irreflexive it is not satisfied. See, whenever it happens to be reflexive, it cannot be reflexive. That is a simple story, my dear friends. Now, what about transitive? What about transitive? See, if you cannot get proof for that, try to get counter example. Just a counter example is enough, sir. Just a counter example is enough. Just a counter example is enough. Counter example is waiting for you. One, 3, 3, 4, that is 1 minus 3 is less than or equal to 2. 3 minus 4 less than or equal to 2. Very good. That is enough. That will do. Yes, correct. 1 minus 3 less than or equal to 2 and mod 3 minus 4 less than or equal to 2, but mod 1 minus 4 is not less than or equal to 2, therefore not transitive. Not transitive. Very good, sir. Very good. So this is also fails. Only R1 and R3. R1 and R3 are equivalence relations. Option B is the correct answer. Option B is the correct answer. Move ahead. Please answer this question. Yeah, please answer this question. Voice break हो रहा है. Hello, hello. Hello. Is my voice clear? आवाज आ रहा है? Hello. Hello, hello. वॉइस ठीक है? See, generally English don't go with communication or grammatical English, my dear friend. At least you could able to communicate what you want to say. Okay, communication is required, not about proficiency in English. Whether you could able to communicate what you want, it is enough. Most of the professors may not be speaking that fluent English, my dear friends. Okay, there are some professors might be speaking, okay, just the way it has to be communicated. It is enough. See, English is just a means of communication or means for communication. Am I clear? Yeah. See, some people have that particular fear, like I am not able to speak in English. They join some spoken English classes also. See, my dear friend, obviously you study everything in English only. The medium of instruction is English only. So same thing you need to explain to them. What you understand, they'll ask a question, you have to explain that in the same language. Okay, that's it. It's not a hurdle for you, my dear friends. It should not be a bottleneck also. What is the answer, sir? See, I'll give you the story. Please remember this properties. You can never forget, sir. Just this table you remember. You can never forget this properties, sir. Okay, you will never forget this properties. Reflexive, irreflexive, symmetric, asymmetric, antisymmetric, and transitive. Suppose R, R1 and R2 are satisfying any of these stories. You can say about R inverse directly. You can say about intersection of two fellows. You can say about union of two fellows. Those who can remember this table can never go wrong in this, my dear friends. And here, in this, only there are three negative cases. That is, union of two asymmetric relation need not be asymmetric. Union of two antisymmetric need not be antisymmetric. Union of two transitive need not be transitive, my dear friend. Except for that, remaining all are correct. Remaining all are correct. Those who can remember this will never go wrong, my dear friends. Now I given the complete hint. Please answer this question. Please answer this question. I given the complete hint, sir. This type of question they can ask 1,000. You can answer them easily. All the questions can be answered just by noting this relationship. Please answer this. What is the correct answer? Yeah, Tushar given correct answer. Tushar given correct answer. Only union of antisymmetric need not be antisymmetric. D, very good. Very good, Lalit. Now next time onwards you don't have to say that I don't remember. Okay? This can be fixed for lifetime, my dear friends. This can be fixed for lifetime. Am I clear? Okay. Welcome, Mr. Ashwini. Welcome to this session. No problem. I think you had your dinner and you joined. No problem. Agla Samasya. Please answer this question. See, this session, what all are possible, I am giving it, sir. There are so many, operations are there. See, I am trying to cover as many things as possible. Okay. See, in 1 hour, you are expecting me to complete sets, relations and functions. Please. Answer this question. Waiting for your answer, my dear friends. And tomorrow we take up some problems on graph theory. Tomorrow we take up some problems on graph theory. Lalit says option D. Not sure. Ashwini, AB de Villiers, Tushar, Satyam, any other? These are the people who are answering regularly, so I just thought I'll call these people. 1023 can't be. Why 1023 can't be? Satyam says A. Super Satyam. Bravo. That's very interesting. Satyam says A. See, my dear friends, there is a set. The name of this particular set, let us call it as some A, whose elements are 1 to 10. Now we are defining 10 sets, S1, S2 and so on, S10. How S1 is defined? It is a 4-element subset containing 1. So 4-element subset means we need to select how many elements? 4 elements. But in that 4 elements, 1 is already selected. In that 4 elements, 1 is already selected. Means how many more elements we have to select, sir? 3 more elements from remaining 9 more elements. So this S1, how many ways we can create S1, my dear friends? Number of 4 element subsets containing, number of 4 element subsets containing, number of 4 element subsets containing 1. How many such fellows will be there? 9C3 will be there. What about S2? What about S2? What about S2? S2 also same, but this time 2 should be there. Story is same. S2 is also 9C3. S3 also 9C3. S4 also 9C3. Continuing this, S10 also 9C3. All these fellows are 9C3. Now the question is sigma Si, where I varies from 1 to 10. That is S1 plus S2 plus and so on S10, which is 9C3, 9C3 and so on 9C3. So what is the answer for this, sir? 10 into 9C3. And 9C3 into 10 how much, sir? 9C3 is 84. 9C3 into 10 should be 840. Option A. Super Lalit Yadav, very good. Very good. Now I think you understand properly why that 840 is the answer for this. Yes or no? Next one. Try this. It happens. Common. Natural phenomena. As I told you, it happens. Common and natural phenomena, not just for you, for many people. Who is answering this? So, set is containing 4 elements. How many relations are there on A? Number of relations on A. How many relations are there on A? How many relations are there on A? Two power n square, which is 2 power 4 square, yani 2 power 16. Now the question is, probability that a chosen relation is symmetric. So we need to know number of symmetric relations on A. Number of symmetric relations on A. Yeah, correct only Satyam, correct, yes. How many symmetric relations are there on A? What is the formula for that? 2 power n into n plus 1 by 2. That is 2 power 4 into 5 by 2. Yani 2 power 10. Is number of symmetric relations 64? Anyone change it nowadays? Lalit Yadav, how many symmetric relations are there on this particular set? What is the formula for number of symmetric relations? Not n into n minus 1 by 2. Symmetric is not n into n minus 1 by 2, n into n plus 1 by 2. So therefore the probability is number of symmetric relations divided by number of relations, which is nothing but 2 power 10 by 2 power 16. Which is 1 by 2 power 6, which is 1 by 64. Very good, Anant Mohan. Yeah, Anant Mohan, today you are not answering questions. I missed your name also, Anant. Last 2 classes you were answering brilliantly, but this class what happened, sir? I am also giving standing ovation for everyone. You are answering? Okay, sorry. Few only you answered today. I haven't seen much of your answers. Okay. See, this is a very common phenomena, or very common for GATE point of view. They mix probability with discrete mathematics, probability with algorithms, probability with data structures, probability even with sometimes CN or OS also. Okay, okay. Good, good, good. Sorry. I think you are just giving. Okay, correct. No problem, sir. Okay. Homework. Homework. This is also super question. This also can be combined with. That can be. Possibility is there. That's why they'll ask. Possibility is there. That's why they ask. Homework noted. Move on to the next topic. Number of lines in Hasse diagram of D24 with division relation. Number of lines in Hasse diagram for D24. See, Dn is number of positive divisors of n. Dn is number of positive divisors of n. So D24 means, what are the positive divisors of 24, sir? 1 is divisor, 2, then 3, then 4, 5 is not, 6, 7 is not, 8, then after 8, 12, then 24. These are the positive divisors of 24. Now this set with respect to division is actually poset, partially ordered relation. The relation is partially ordered relation. A set together with partially ordering relation is what is known as partially ordered set. Lalit Babu, check your answer. Those who are not using pen and paper for mathematics, they are doing a crime. It is a crime. Okay? It is a crime. I am using pen and paper. How logical the subject may be, the concept may be, you require a pen and paper. For mathematics, those who do in air, that is wrong. See, in air, what happens is magic. Mathematics is not magic, it is logic. This is my statement. Remember, mathematics is logic, not magic. Those who understand the logic properly can do the magic. With pen and paper or still visualizing? With pen and paper or now visualizing? So here, okay, but that is not a good practice. Not a good practice. Please take a paper. See, rough paper also will do, sir. No need of writing in a proper note, sir. Any paper. Am I clear? That is good. Good for health. See, I always remember my 10+2 mathematics faculty. Okay? He says, small sheet of paper. He says that I'll solve 12 marks questions on that small piece of paper. So how confident he should be, but still he uses the paper. Anant Mohan, 8 is wrong. Shyam Nayak, Satyam Nayak, you still visualizing. Lalit Yadav missed some lines. Let us see the story. See, we start with 1, 2. What are the fellows which are related to 2? 1. No one is covering, so 1 is not covered by anyone, 2 will take the responsibility. Next 3, who are related to 3? Only 1. Anyone covering 1? Anyone covering 1 in this list? No one covering, so 3 take responsibility. 3 says Mehuna and it will cover 1. Then comes 4. Who are related to 4? That is, who are related to 4 means less than 4 which divides 4. What are they? 1, 2. But 1 is already covered by 2. So 2 is covered by 4. 2 is covered by 4. That is 4 covers 2. Then comes 6. Who are related to 6? 1, 2, 3 are related with 6. But 1 is already covered by both 2 and 3. Now 2, 3 are not covered by anyone. So then what 6 will say is Mehuna. Okay, so 6 will take responsibility of both 2 and 3 and 6 will cover both 2 and 3. 6 will cover both 2 and 3. Then comes 8. Who are related with 8? Who are related to 8? 1, 2, 4 are related to 8. 1 is already covered by 2. 2 is already covered by 4. So now for 4, who will take the responsibility? 8 will take responsibility and 8 will cover 4. 8 will cover 4. Next comes 12. Who are related to 12? 1, 2, 3, 4. That's 6. 1 is already covered. 2, 3 are covered by 6. Now we have 4, 6. No one is covering them. So don't feel bad. 12 take responsibility. 12 says Mehuna and 12 covers 4 and 6. Whatever way you want. Then finally 24. Who are related to 24? All the fellows. 1, 2, 3, 4, 6, 8, 12. All these fellows are related to 24. 1 is already covered. 2, 3 are already covered. 4, 6 are already covered by 12. 8 and 12 no one is covering. So who will take responsibility? 24 will take responsibility. Now you count number of lines, my dear friends. Now you count number of lines. So number of lines in the Hasse diagrams is equal to 10. So we have 10 lines in the Hasse diagram, my dear friends. 10 lines. Super. Please try this as homework. Please try this as homework, my dear friends. All of you, please try this as homework. The next one is, which of the following is a lattice? Which of the following is a lattice? Which of the following is a lattice? Only A is lattice, B is not a lattice. What is a lattice, sir? A lattice is a poset in which every two element subset or every pair of elements having LUB and GLB. A lattice is a poset in which every pair of elements having LUB, least upper bound, and GLB, greatest lower bound. Satyam Nayak says B, Lalit Yadav says A. After giving definition, Anant DB, I think, vanished today. Harveer Singh sir, good evening sir. Welcome sir. I want all of you to welcome the mechanical genius Harveer sir for my session. B. Anant Mohan says B. Yes sir, good to see you too. After shifting to Hyderabad, not get chance to talk to you people. We'll connect shortly. Yeah. So my dear friends, here if you observe, there is a simple test, you can do it, or you can call it as a shortcut also my dear friends if you want. The simple shortcut is, whenever you find this kind of diagram, crossover, whatever you call it, okay, whenever you find, hi Amreen, welcome, good evening sir. See, whenever you find such a crossover, you can say it is not a lattice, because if you consider BC, if you want to find upper bound, actually what upper bound we need? Least upper bound. For BC, both D as well as E both are upper bounds, but I need least fellow, least upper bound. Yeah, whatever shape, different people uses different ideas for that, whatever way you call it, whenever you find it is not possible. That is the simple logic. Now DE both are upper bound, but I need least upper bound. But DE are not comparable. DE are not comparable. Comparable means either this should be smaller, related to this, or this should be related to this. They are not comparable at all. So how can you say which one is least? So these two fellows will be fighting, and their fight will never end, and will never get least upper bound. So LUB not possible. LUB not possible. Therefore it is not a lattice. It is not a lattice. So that is a simple test you can use my dear friends to identify whether it is a lattice or not. Just identify whether that kite shape, whatever you call it, or you call it as a crossover, whatever you call it. Okay, whenever you find that, okay, whenever you find this, that is two fellows are joining. Two fellows are joining at 2 points. Two elements are joining at 2 points which are not comparable. We call them as joins, okay, which are not comparable. Who is from ACE Academy? Oh. Right. So which are not comparable. Then what happens? There cannot be LUB, my dear friends. Therefore, what happens? This cannot be a lattice. See, whereas this fellow is a lattice. See, simple logic is the elements which are related with each other. Obviously, there is a LUB and GLB, my dear friends. Wow. Shambaji Bosle, very good. Welcome, sir. People still remember me after a long time. Yeah. So now BC. These are the only fellows, because when either A related to B or B related to A directly, okay, either A related to B, B related to A directly, their LUB, GLB guaranteed. Only the fellows which are not directly related, or not comparable, for them you have to find LUB, GLB. So for BC only we need to find LUB, GLB. For BC, LUB is D, GLB is A. So for every pair of elements, LUB, GLB is there. Therefore it is lattice. That is only second figure is lattice. Whereas first figure is not lattice. Dear friends, I was in GATE field from past 12 years, and the mentioned place I was almost around 8 years. I was teaching there for almost 8 years. Okay, so let us continue with my next problem. Please tell me, next one. in the lattice defined by the Hasse diagram in the given figure, how many complements does the elements E have? This fellow E is having how many complements? I just move little further. I think this side I should move. Okay. So let me take the next slide where I have the same diagram. I think at the same place I kept. I just moved to the right place so that you can answer this. So how many complements this fellow is having? What do you mean by complement, sir? See, we say that B is complement of A. We say that B is complement of A if A or B should be equal to 1 and A and B should be equal to 0. What is 1 and what is 0, sir? Greatest and least element. This is 1 is greatest and this is least. Okay, so if you observe for E, C will do the same activity. C or E will be greatest element. This is your greatest element and this is the least element, sir. C or E is greatest element. C and E is least element. Similarly, C or B is greatest element. C and B is least element. C or A is greatest and C and E is least element. Similarly, the same story, not C, sorry, I'm sorry. E or C will be greatest, E or C will be least, E or B will be greatest and E or B will be least. Similarly, E or A will be least, E or A will be greatest and E and A will be least. Same is the case with E or F and E and F, my dear friends. Previous answer, if you want to understand, you should know the definition of lattice, my dear friend. If you don't know the definition of lattice, then the problem starts for that. Okay, first let me complete this, I'll come to that. So for E, what are the complements? What are the complements? All these fellows, A, B, C and F are complements. So how many are there? 4 complements. Very good, Anand Mohan. Amreen, 4 complements. So for Amreen, I'll give you this simple idea. Just remember this. Whenever you find two non-related elements, from there the horns are going, no? They should go and meet at a single point. If they meet at two different points which are not comparable, then it cannot be lattice. So whenever you find such fellow, it is not a lattice. Whereas here, these two fellows are going and joining at only one place, therefore it is a lattice. Am I clear? So that is the basic idea which you need to understand, my dear friends. Hope you understand. Amreen. We are about to conclude the story, sir. Number of surjective functions. How many surjective? Means onto functions. Surjective functions is same as number of onto functions. Number of onto functions from a set having 5 elements to a set having 3 elements. Number of onto functions from a set having 5 elements to a set having 3 elements. Please answer this. I have one more question to conclude this story, sir. Waiting for your response. It is not Sterling's number. It won't work. For small numbers it may, but otherwise it will not. So here we have the formula. Set A is having n elements and set B is having m elements, and number of onto functions. Number of onto functions from A to B. Here number of elements in A must be greater than number of elements in B. So the formula here is given by MC0 minus m power 0 m minus 0 whole power n. So this minus 1 power 0 minus 1 power 1, this fellow, what actually it will do is it will give you alternatively plus minus signs. So you can directly write this as MC0 m minus 0 whole power n, alternatively plus minus sign. So next is minus sign, minus MC1 m minus 1 whole power n plus MC2 m minus 2 whole power n. Like this it continues, sir. Alternatively you get plus minus sign till you get 0, my dear friends. Nice. So here m is 3 and n is 5. N is 5, sir. So it is 3C0, 3 minus 0, that is 3 power 5, 3C1, 3 minus 1 whole power 5, 3C2, 3 minus 2 whole power 5. Actually next term 3C3, 3 minus 3 will be 0, my dear friends. 3 minus 3 will be 0, my dear friends. Now this 3 power 5 is 243, 3 into 2 power 5, 3 into 1 power 5. I think 246 minus, this is 32 na? 32 3s, 96. So I think it is 150. Super Anant Mohan. Anant Mohan is rapid fast with this type of problems. See, the proof of this particular one is based on the inclusion-exclusion principle. It is based on inclusion-exclusion principle. The proof is beyond the scope, my dear friends. See, inclusion-exclusion principle, we have mainly three results, main results. One is derangement formula, the second one is Euler-Pi function, and the third one is number of onto functions. These are the three main formulas which are derived using the inclusion-exclusion principle. Okay? So the derivation is beyond the scope, don't worry about it. Got it? So the answer is C. Hope you understand. If you want, you can write it as, MCI minus 1 power I, m minus I whole power n, where I varies from 0 to what? Maximum m. This is the summation formula, sir. Summation notation, you can write the same formula like this. The same formula can be written using summation notation like this. This was a GATE question, IIT Kanpur. So last time when I was doing GATE IIT questions, this question was missed. So I just thought I'll do it to conclude today's class. So last problem for today. Anyone knows this? Actually, the same problem is also given for percentile 2 later on, and percent divide by 2 also. It's actually linked answer type question, sir. Thank you, Lokesh Kashyap. The next problem. See here, a partial order is defined like this. Here x by y means division, sir. See 0, 0 belongs to that partial order. Okay. And AB belongs to partial order if and only if A percentile 10 is less than or equal to B percentile 10 and A by 10, B by 10 belongs to 10. It is given recursive definition. It is a recursive definition, my dear friends. It is the recursive definition. It is the recursive definition. See here, what you need to understand is when you do percentile, for example, if you have 256, whenever you do percentile operation, you get last digit, my dear friends. Percentile will give you the last digit. Reminder. Whereas division will remove the last digit. Division removes the last digit. So these two, if you understand, then this problem is very, very simple, my dear friends. This problem is very, very simple. Anant Mohan says option B. Let us verify. See here, we start with option A, 101 and 22. See what we need to do is, see here, the recursion if you understand, it's very simple. We check the percentile. Percentile means what's the last digits you are comparing. If last digit of first number is less than or equal to last digit of second number, then remove last digit and again continue the recursive process. Okay, so let us see this. First, what you do is you compare last digit with this. 1 less than or equal to 2. 1 less than or equal to 2. Yes or no? 1 less than or equal to 2. Is it correct? Yes. If it is correct, remove the last digit and continue the same process. Last digit you remove here, last digit you remove here. Again compare last digits. Is 0 less than or equal to 2? Is 0 less than or equal to 2? Yes. So again remove the last digit. Here if you remove last digit means single digit, if you remove you get 0. So 1, 0. Now again you compare the last digits. Is 1 less than or equal to 0? Is 1 less than or equal to 0? Is 1 less than or equal to 0? No. Therefore, this fellow is not continued further. So what happened? This is failing. So you stop. This will never happen. So this is not belonging to the P. So now let us consider the second one. 22 and 102. 22 and 101. Again the story is same. Compare last digit. Is 2 less than or equal to 1? Is 2 less than or equal to 1? Is 2 less than or equal to 1? Correct or wrong? No, right? 2 cannot be less than or equal to 1, so it is wrong. Fail. Stop. 2 less than or equal to 1 nowadays, huh? Option D, Ishwar, very good. You joined late, but you're giving beautiful answer. No. So, B option is gone. Next, 145, 265. 145, 265. Compare these two fellows. 5 and 5. 5 less than or equal to 5 is? Yes. So, what we do? Remove last digit. 14 here, 26 here. Because 5 less than or equal to 5 correct, then you move. Otherwise, you stop there. Again, compare 4 less than or equal to 6. 4 less than or equal to 6. Yes, correct. Move further. Remove last digit. 1, 2. 1 less than or equal to 2. Yes. Therefore, remove 0, 0 which belongs to P. That means C belongs to P, my dear friends. C belongs to P. So now we'll check the last one, 0 and 153. 0 and 153. See, once it is 0, always it becomes 0. Even if you divide by anything, divide by 10, it always gives you 0, 0, 0 only. So here first you compare 0 with 3. 0 less than or equal to 3? Yes. Continue further. So 0 will remain 0 only. Here last digit is removed, 15. 0 compared with 5. 0 less than or equal to 5? Yes. Remove last digit. It is 0 only, it is 1. 0 less than or equal to 1? Yes. Now it becomes 0, 0, which is belonging to P. That means third and fourth belongs to the given partial order. They belong to given partial order, my dear friends. Hope you understand. Is the idea clear? Yes. Super. So they are asking such beautiful questions in IIT Kanpur. Generally, IIT Kanpur is famous for mathematical questions, good mathematical questions, sir. So be ready. So that's all for today, my dear friends. And there are all, some GATE preparation free ebooks are available under download. See in the chat box or below that you can find all these links given. Am I clear? And the scholarship tests they are conducting, and free GATE workshops are also conducted regularly. So please check the description box for these details, my dear friends. If you have any other doubts, general doubt, you can ask me. Otherwise, that's all from me today. Okay, we can call it a day. Tomorrow, 8:30 p.m. graph theory, the last topic. We take up problems on graph theory. So shall I call it a day? Any doubts you can ask? Otherwise, thank you for attending the class. Keep attending all the sessions, not only mine, all other sessions, because practice you need to take different sources, my dear friends, for practicing. Okay. All other faculty are also coming up with some beautiful questions. They are creating some beautiful questions. Okay. So please go through those questions so that, okay, you already completed the topic, then it would be a quick revision, my dear friends. Okay. That is the idea. Hope you all enjoyed this session. Please subscribe, like, Toko. Okay, that's all for today. If you have any general discussions, please ask me. I am waiting for your general doubts now. Otherwise, we'll call it a day. Okay, thank you, sir. Thank you very much. That's all for today. Surely, sir, I'll take some advanced topic session later on. Surely further. Okay? Surely I'll plan for that.